Hi, everyone. Welcome back to Math 160. I want to finish Unit 1 notes so you don't even have to worry about that on Monday. So let's switch over to page 14. We have practice problem number 5. So I want to look at those really quickly and fill in the blanks for you so that you understand which sampling technique goes with which statement, and then we'll finish the notes together, okay? Let's check this out. Number 1, the CBS Evening News asks viewers to use a call-in number at the bottom of their screen to give their opinion about legalizing marijuana. So notice that out of our sampling methods above, this is definitely volunteer. Perfect. They're calling in, they're taking it upon themselves, so they're volunteering themselves to participate. M&D Bank is auditing its check cashing service to ensure accuracy. All checks are previously inputted into a computer by check number, and the computer randomly selects 50 checks for the auditor to review. This is simple random. So you're using a number generator to just randomly select 50 of the checks. No big deal. There's no rhyme or reason that is associated with that. Number 3, lucky students in a PE class are being selected to run a mile. Don't you remember that? Ugh, gross. Anyways, all students line up and every 5th student is chosen to run. That's huge. Just by noticing that every 5th, we see that we have systematic. That is our systematic sampling. MCC wants to determine how students from different racial backgrounds are planning to vote in the next presidential election. So they group the students by race and survey 100 students from each group. Notice that there's a strategy behind divvying up the students. So we're using stratified sampling for this. Number 5. Charlie works for a new protein powder company. He believes that a list of stores he chose would be a good representation of the population. So he has customers at those stores try the protein shake for a few months and collects their opinions. So he chose these particular stores, which means he's using judgment sampling. And last but not least, an organization is looking to survey the performance of smartphones across New York State. They divide the entire state's population into groups by counties and then randomly selects the same number of people from each group. Notice all they did was divvy up by counties. That's not particularly a strategy in terms of what we use for number 4. Notice for number 4, we divvied up group by race. Here, even though we are just divvying up the population by their counties, essentially these people have chosen the counties in which they live. So that's their own prerogative, that's their own perspective, and then you randomly choose from those groups. So that is representative of cluster sampling. Okay, let's continue on our next page with potential sampling pitfalls. So we have something called misleading conclusions. So this essentially, we're just going to be writing a lot of definitions on this page, which is why I wanted to do this, separate from our class time. So misleading conclusions. When forming a conclusion based on a statistical analysis, we should make statements that are clear, even to those who have no understanding of statistics and its terminology. We should carefully avoid making statements that are not justified by statistical analysis. So we want to make sure we are not providing misleading conclusions in the way in which we analyze our data. We also want to keep in mind that common phrase of correlation does not equal causation. That's really important to keep in mind. We don't want to say one thing is because of another if really they're just correlated and not causing one another. We want to be really, really careful with that. In terms of the next potential sampling pitfall, we have self-reported results. I have an example here to really drive home this idea. So let's say that you are working with a trainer and you have fitness goals, and the trainer asks you to take measurements. They want you to report your weight. They want you to report your waist size, your bicep size, your quad size, all sorts of different measurements. What could go wrong? Well, that trainee may feel pressure to perform really, really well, so that person may not provide honest results. You know, maybe they are asked to follow a certain diet plan and they're reporting following the diet plan, but maybe they're not actually following it. So self-reported results could have quite a bit of error, especially if people feel like, oh, they don't want to be totally honest because they're worried about the impression that they're going to make. Next, we have to consider sample size. So we need to make a note that conclusions should not be based on samples that are far too small. With a small sample, there isn't enough data to adequately reflect the population from which a sample was pulled. It's like saying, I want to figure out the favorite ice cream of students at MCC, but I only ask 7 students. In no way is that representative of the entire student population. You need to consider something called power, right? It's the power of that particular sample. So we want to make sure that we are getting enough responses that actually reflect the population. One of the ways in which we do that is we look at the demographics and we try to find out whether or not our sample reflects those demographics in terms of proportion. So that's one way to do it. The general rule here is that if you're pulling data, you want to make sure that you have 30 pieces of data or more, n is equal to 30. But honestly, if you were looking at a population as large as the student body at MCC, which has like 10,000 students, you want at least, I would say 1,000 would be a great point to show that you have a lot of data that would be representative of the population. And again, make sure your demographics are in line. Next, let's look at loaded questions. So if questions are not worded carefully, the results of a study can be misleading. Here's an example of a loaded question. Should the government continue to exploit the habitat of the polar bears in its greedy pursuit of oil? If that's not loaded, I don't know what is. It is so biased to one particular perspective that it just feels like you're being asked a question to kind of support the researcher's point of view. So you want to be really, really careful with asking loaded questions like this. When I think about a question like, should the government continue to exploit the habitat of the polar bears in its greedy pursuit of oil? Maybe you can ask, something along the lines of, should the government continue to search for oil in natural habitats, inhabited by polar bears? Something like that. That's a little less loaded. It still is kind of like a little iffy, but at least it's you're not using words like exploit and greedy, things like that. Hopefully that makes sense. Next, we have non-response, and this is just simply people refusing to answer. And when people refuse to answer, that could potentially skew the results. So as an example, if the local governments are trying to collect data from their Common Core practices and how students are doing, when parents opt out students, there's less data to collect. There's less data that would actually help to inform better practices, unfortunately. So whether or not you agree with it or not, it does eliminate the availability of data that would help to inform practices. And lastly, we have missing data. So results can sometimes be dramatically affected by missing data. So as an example, let's say that you were trying to collect information from, I guess students at MCC, we could do this, or students in Rochester, or people in Rochester, residents of Rochester. If you are asking to collect information about income, people in low socioeconomic status, they're less likely to report that. They're less likely to report what they're actually making. Sometimes it's just an issue of trust and feeling like what's going to happen with this data, but it really takes away from that bigger picture. So these two kind of seem like they go hand in hand in the sense that people will choose not to respond, or you'll just frankly have missing data, and those are slightly different. I do want to point out that with non-response, I want you to consider that the results can be dramatically skewed with the non-response, which means that certain demographics may be over or even underrepresented. So that's why these two are definitely potential pitfalls in your data. Perfect. And with that, we are done with Unit 1. So I hope this video helps you to understand the very last piece of this unit, all those potential pitfalls, and that you should be able to complete all of your homework for Unit 1. I will see you all on Monday. Bye.